Hi everyone. So the next algorithm we're going to talk about is merge sort. Now, we've talked about selection sort and we've also talked about bubble sort, but both selection sort and bubble sort are algorithms which we consider slow. And when we talk about efficiency later on in the next few weeks, we'll start to understand exactly why mathematically those are slower functions. However, merge sort is the first actual sorting algorithm which is extremely efficient, and so it's the type of sorting algorithm that, for instance, Python uses to build its own sorting function. So merge sort is a very interesting algorithm because it relies on a premise of logarithmic and exponential growth. And we'll look at this in an example. So let's say that I have the list 4, 6, 2, 8, 1, 5, 6, 9, 3. So I have this list and it has 8 elements, 4 and 4. So what merge sort does is that it relies on the basic knowledge that it's actually really easy to combine two sorted lists. Like, let's look at an example. So let's say I have A equals 1, 3, 5, and I have B equals 4, 7, 9. And I want to combine, actually let's put a 2 here. I want to combine these two lists to form one sorted list, C. So the way that we do this is essentially we know that this is sorted and we know that this is sorted, which means that the smallest possible element in all of these lists has to be either this first element or this first element. So what we do is basically just look at the first elements of each list and bring down the smaller one. So I bring the 1 down here. So now we put the 1 here so we get rid of it here. Now, once again, I do the same thing. I compare the 2 with the 3. So the 2 is smaller, so I bring that down. Get rid of it in from B. Now I compare the 3 and the 4. I bring the 3 down. I compare the 4 and the 5. I bring the 4 down. 5, 7, 5. And then all that's left is the 7 and the 9. So I can bring down the 7 and the 9. And by doing that, we essentially went from two sorted lists to one large, completely sorted list very easily. And so merge sort builds on this premise and essentially utilizes it to create a very fast algorithm. So let's go back to this example where we have list L is equal to this. So the first thing that merge sort realizes is what is the smallest possible list which I know is already sorted, because we need to start with sorted lists and then merge them together. So it turns out that the easiest list to sort is a list of size 1. So we basically pretend that each element is a list of size 1. Because if I asked you what is the sorted list of 6, the answer is the list of 6. So we can see that all of these lists are actually sorted. Now what we do is we take pairs of the lists and merge them using the algorithm we just discussed. So 4 and 6, I compare the 4 to the 6 because they're the first elements, and I bring down the smaller one. And then I can have the 6 is done, so now I bring down this. The 4 is done, so now I bring down the 6. So those two lists were combined. Now if I want to combine these two lists, I do the same thing. So I bring down the 2 because it's smaller, then I bring down the 8. Here I bring down the 1 because it's smaller, then I bring down the 6. And here I go first the 3 because here I compare the 9 to the 3 and I bring down the smaller one, then I have to bring the 9. So now we have lists of size 2 that are sorted. So now, as you probably guessed, we essentially just combine these lists and sort them. So now I'm combining the list 4, 6 with the list 2, 8. So like we did before, essentially we look at the first element, 2 and 4. We bring down the smaller one, 2. So now we're done with that, so we compare 4 with 8. We bring down the 4. Now we compare 6 with 8, and we bring down the 6, and then we bring down the 8. Do the same thing on this list, so we bring down the 1, then the 3, then the 6, then the 9. And finally, we combine these two lists that are both sorted, and we put them into one large sorted list. So we compare the 1 with the 2, we bring down the 1, then the 2. So now we have 3 compared with 4, we can bring down the 3, 4 compared with 6, bring down the 4, 6 compared with 6, it doesn't matter, we'll bring down the 6. Then 6 compared with 9, we bring down the 6. 8 compared with 9, bring down the 8. Then 9 is the last one, so we bring it down. And so, as you can see, we've actually gotten a sorted list here. And all we did is we just broke up the lists into a list of size 1, and then kept combining them together until we got to finally the sorted list. So this is the basic algorithm, and you should look over this example that I went over and make sure that you understand exactly how we do the merge operation and how it ended up becoming sorted. Now the next thing that you want to do, or now that what we're going to do, is look at the actual code, because there's two parts to the code. The first part is the actual sorting function, which implements what I just talked about, but then additionally there's the function which does the actual merging. So the merge function takes two lists and merges them into one sorted list. So, hi. So what we're going to do is essentially just walk through the code at a high level and try to understand what's going on. So the first thing that we have to realize is the step variable. Now what the step variable does is it basically tells us what is the size of the list which we are currently merging together. Now if we go back to our example, in the first iteration the step variable would be 1 because we're combining two lists of size 1. Then the next pass it would be lists of size 2, so step would equal to 2. And then the next pass step would be equal to 4. So as you can see, when we're combining lists like this, the size of the list that we're creating actually doubles at each pass. And so our step variable, which is telling us what the size of the list is that we're combining, is going to be doubling as well. So right here, we start our step out at 1, and then every time we do one iteration of this while loop, we do step times equals 2. Now, it's interesting to note that the step is the size of the sorted list, so when the step is less than n, we keep sorting. However, when the step becomes greater than or equal to n, that means that we have a list of size n or greater which is sorted, which means that our entire list is sorted and then we're done. So this while loop essentially says, in this algorithm, first do this step, then do this, then do this, then do this. Now, this inner for loop is actually going through the process of merging the two lists together. And in this merge sort example, we're actually merging the list in place. So it's not that we're actually breaking it up into smaller lists. We're just, for instance, inside of here, we're swapping the 3 and the 9 when we're merging those two lists. So like 9, 3 right here would be 3, 9, and that's what this would be. So what we're saying is we have a few different variables to keep track of. We have the start of the first list, which is start 1, the start of the second list, which is start 2, and the end, which is the end of the second list. Interestingly, this end of the first list is just the start of the second list. So, for example, on the first pass, our S1 is going to be 0, so where the 4 is. S2 is going to be where the 6 is, and end is going to be where the 2 is. So we're saying combine this list and this list. So basically, if you look at this for loop, it's essentially starting from 0, going up to n, and jumping by 2 times step. So essentially it's going to first take care of these, then take care of these, then take care of these, and finally take care of these. So essentially it's looping over, the for loop is jumping by lists of size 2 times step. So our start 1 is just the beginning where the for loop is at that point. The start 2 is basically start 1 plus the step. As in we go, if our step is 2, that means that we're combining lists of size 2. So for instance, we'll say this is the first list, and the second list is start 1 plus 2, which is this. Then the end, similarly, is start 1 plus 2 times step, because we get the first list, then the second list, and that's where the end is. Now notice how we say start 2 and the end is equal to the minimum of this or n. Essentially what that's saying is that imagine that we have a list which has some odd number of elements, or not a power of 2. Now, we might say start 1 might be over here, in which case start 2 would be here, and the end would be off the page. So essentially we're saying that if we get to the end of the list, then just use n as our start 2 and our end, which is fine. Then essentially all that we have left is we say, okay, we have the beginning of the first list, the beginning of the second list, and the end of the second list. So let's merge those two lists that we have basically sliced out, and let's merge them together. So now let's look at the merge function. Now the merge function, as I said, is going to be merging lists in place. And so in this situation, essentially it's taking in the list, it wants to merge the starting index of the first list, the starting index of the second list, and then finally end of the second list. So everything between start one and end, after this merge function is called, should be sorted. So essentially, remember in this algorithm, I said, if we want to merge this list with this list, then I just start at the beginning of each list and bring down the smaller element. So essentially, what index 1 is where I am in the first list. Index 2 is where I am in the second list. So essentially, it would be like I1, and then here would be I2. Then when I bring down the 1, I say, okay, the 1's done, so now I'm looking at the 3. Then it compares the 2 and the 3. The 2 is smaller, so then it brings down the 4. Now it's comparing the 4 and the 3 is smaller, so it brings down the 3 and says, okay, now look at 4 and 6. So index 1 and index 2 are where we are in the first list and the second list. Now what we're doing is basically building up this auxiliary list. So we're going to basically combine the two lists into another list, and then finally at the end what we do is we're saying, okay, I made this auxiliary list. Now let's just bring all of those elements and put them into the original list destructively, so that the original list is now sorted in the places that we want it to be sorted. So if we look at what's happening, essentially, so the length, like we thought, is going to be the end minus start 1, which is the size of the two lists combined. So we loop through and we say, okay, if index 1 is equal to start 2, so let's think about what that means. If where I am in the first list is the beginning of the second list, that essentially means that I'm in this scenario where I've gotten to the end of here, and so I've actually used up all of the elements here, which means that everything left in the other list is in sorted order and it's larger, so I just keep bringing those down. So if I'm at the end of the first list, then just bring over the element from A, which is in the second list, and then, okay, look at the next element in the second list now. Additionally, if the index in the second list is not at the end, and the element in the first list that I'm looking at is greater than the element in the second list. So let's say, for instance, that the element in the first list is 6, the element in the second list is 3. So 3 is smaller than 6, so I want to bring down the 6. So in that situation, I also bring the element from the second list into our auxiliary list and say, okay, get rid of that second element. The other situation is when essentially this is not true, that the element at the first index is actually smaller than the element at the second index. And so in the else case, I essentially say, okay, instead of doing that, let me just bring down the element from the first list and now move on to look at the next element in the first list. So by doing this, and you should look at this offline and essentially convince yourself with examples that this works. By doing this, we basically populate the auxiliary list with all of the elements from the first list and second list merged into one sorted list. Now, we have done this. Now we actually need to bring those elements back into A, so A is destructively modified. So what we do is we loop from the start to the end, and essentially, so this is looping through A. We're saying A at that index should be equal to the auxiliary list at that index minus start 1. So in the first value of I is start 1 minus start 1 is equal to 0. The next value of I is 1, or start 1 plus 1, so start 1 plus 1 minus start 1 is equal to 1. So convince yourself that this is essentially looping from the beginning till the end of the auxiliary list and putting it into the correct location of A. So if we keep merging all the lists together, then after one pass, we will go from here to here. And then we increase our step by 2 and do it again and go from here to here. And finally, we'll get to a sorted list. So yeah, merge sort, as you can tell, is pretty complicated, and it's one of the harder algorithms that we're going to go over in this class. However, it's really interesting and actually makes a lot of sense if you spend some time thinking about it. I would advise that you essentially walk yourself through the code, write it yourself and try to figure out how it works, go through some examples, and get a very good intuition for what's happening so that you can better understand it. Thanks.